Hi people, I am WenHui, and today I will be using basic dynamic tools and an advanced dynamic tool to do an analysis on a malware known as the whooping gun. But before I begin, I would like to give you a short background about whooping gun. Whooping gun is a Windows 32 malware that consists of backdoors. It might drop several files or copies of themselves when it is running in the system. Also, open ports or connect to servers to allow remote users to connect to an affected system. Once a successful connection is established, the remote user executes commands on the system, such as to delete files and folders, download and execute files, and terminate processes. In addition, it has the ability to gather information about the affected system and steal information such as log keystrokes, passwords, and other user credentials. Before running the malware, please do remember to take a snapshot. Like this. Previously, I have done it. And I call it clean. You will be required to come back to this page during the process of analysis. So now, I'll unzip my malware folder. Open up my Process Explorer. And do take a look at all the processes which are running currently. Next, move on to my process monitor and open it. Close the filter pane while waiting for the processes to be loaded. Alright, now start executing your malware. This malware will be gone when it is executed. As you can see, there is a new process being created, which is known as the svcs host.exe in caps. And now, do take a look at all these DLLs. Do check out if there are any mutant type like this, because when mutant exists, this shows that mutex is created, which also means that files or any important documents in the system are open up for sharing. Do remember the process name and the process ID for future investigation. Like here, you will need it because you will have to filter it in the process monitor. So, like I said, the PID is 2096. So I add in. Okay. Filter again. Process name. cvhost.exe in caps. Okay. Hold on for it to load. And as you can see, the type key, file, thread, you may use it for filtering. So go to operation, create file, okay, filter again, operation, probably close file, Next, search for register key. Register close key. Then create key. Delete value. Load key. Open key. And set value. Then we shall try again. Whoa. So, as you can see, it's clear that this particular process which the malware is running takes part in quite a few process operations, which also gives you a better idea of what is this process doing. Or in other words, what is this malware doing? You can see they create file, close file, open register key, close register key, and many more. You can continue with probably thread create, because previously we saw some thread in the process explorer. So we shall browse through if it exists. So basically this is what you can do using process monitor. Alright, so now I close process monitor, I close my process explorer, and I'll move on to another basic dynamic tool, which is also known as netcat, and it will be used using command prompt. Basically, netcat is for users to know which protocol this particular malware is listening to. So I am trying to listen to both ports. First, at the left hand side, I would listen to the HTTP protocol. For the right side, I'll be listening to HTTPS protocol. 443. Earlier on, I have tried this netcat, and unfortunately there are no results. So I concluded that this malware isn't connecting to any of the protocol, so it's not making any connections. So I will stop this process here. You can try to wait longer if you want to. Alright, moving on. I'll go back to my clean page and try out some other basic dynamic tools. Alright, so now I've come back to my clean page. Once again, unzip my malware folder, extract, for now, leave it as it is. Do not execute the malware. Then, open up your red shot and take your first shot. While waiting, open up the Append DNS. At this portion, you are supposed to type in your local address, which is, for my case, it will be 127.0.0.1, and I'll start the server. Put it aside, close the window. Alright, now I have the red shot at the left, Append DNS at the right. Now you may begin to execute your malware. Okay, it's confirmed that it's running currently. So you can take your second shot now. Press compare, and Append DNS will show you this notepad. Basically, here are the register keys which has been added or edited or deleted. Well, for this case, I have seen keys created, values added, values modified, and over here at the Append DNS, you don't see any suspicious URLs, so you can stop the server or let it load longer. But because previously I have done it earlier, and it does shows that this malware does not lead the victim into another server, so I will stop the system. I can close DNS, and for red shot, basically it shows more information about the register keys and what the malware has done to it. I will also close it and close it. I'll go back to a new clean page so that I will begin with this analysis using other tools. Alright, because this is the clean page, I got to re-extract my malware folder. Now I'll be using the last basic dynamic tool, which is capture back. Alright, as you can see, capture back display all the processes which the system is handling right now. Alright, I'll put it in the middle so it'll be clear. So earlier on, you have already figured out that the process which the malware is running on is the scv host.exe in caps. So we will try it out again. Execute the malware. Alright, and now take a good look at this capture back. Do try to take note if there's any svc host.exe. This is in small letter, so it is not related to the malware. However, as you can see over here, like my mouse is pointing, svc host.exe in capital, and there's a lot of DLLs folder being executed. Alright, because this capture bed is moving very fast, you got to hold on to it to have a good look. Alright, so basically here are all the DLLs which are loaded. Basically, a capture bed is also a good tool to figure out what are the processes, what is the malware process doing. Right, you can see over here. Basically, it's just here. Alright, now I will stop and go back to a clean page. And the next part of it, I would start to demonstrate using advanced dynamic tools. So now go back to my clean page. Alright, once again, I've come back to my new clean page, and I got to open up my zip folder. Alright. Okay, I have it here. So for now, I'll be using advanced dynamic tool, which is also known as ODDBG. Open up oddbg.exe. Click yes. Over here you'll see a file. You open. Go to where your malware is located. For my case, it's desktop. Malware 2. Malware, and I open up. Click OK. Alright, now I have the codes which this malware consists of. Basically, ODDBG is a debugger that emphasizes on binary codes analysis. So as you can see, here are all the binary codes, and it is useful when source codes is not available, as it traces registers over here, registers, and recognizes procedures, API calls, switches, tables, contents, and strings, as well as locates routine from object files and libraries. Right, so we can try to debug, and it will stop when there is an error. For this case, it stopped at this particular line. So you can double click. So you can check. You can see the registers. What we have here currently is, you can see a DDL file that terminates process or call some system. Right, so you can see a leave critical section, and still have lots of processes going on. And right, you can see like all the register keys, different register keys, different functions. Different commands. Right, as you can see, different commands. Shift, call. So basically, it gives you a better idea of what this process is going through. Right. So In other words, this OLEDBG is like an advanced tool of IDA Pro, which also look into codings. Yeah. So with this OLEDBG and those previous basic dynamic tools which I have demonstrated earlier on, I'll be able to conclude that this particular malware, which is also known as the hoping gun, is a Trojan, and basically what it does is like it did some changes to the register keys, it did terminate process, it did like create files and many other more processes. So I've come to the end of my demonstration, and thank you for your attention.